Intro. Hi everyone! Welcome to Channel Name. I'm really excited to have you here today because we're going to dive into something that many people find tricky at first, but by the end of this lesson, you'll be really confident. And that's surds. Now, surds might sound like a complicated topic, but don't worry. We're going to take it step by step. You'll learn what a surd actually is, how to simplify them, how to add, subtract, multiply, divide them, and even how to rationalize denominators. I'm going to explain everything in a clear, easy-to-understand way, and I'll include plenty of examples so that you can really remember each step. By the time we finish, surds will feel simple, and you'll be able to tackle any basic Year 9 surd question with confidence. So let's get started and make maths easy. What is a surd? First things first. What is a surd? A surd is a square root that cannot be simplified to a whole number. It might help to think of it as a root that just stays rooted. It won't turn into a nice, neat number. For example, the square root of 2 and the square root of 3 are surds, because if you try to simplify them, they will never become whole numbers. They just stay as they are. On the other hand, the square root of 4 is not a surd because the square root of 4 equals 2. That's a whole number, so it doesn't count as a surd. Here's a memory tip. Whenever you see a square root, check whether the number inside is a perfect square. Perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, and so on. If the square root is one of these numbers, it's not a surd. If it's anything else, it is a surd. So, remembering the perfect squares really helps when identifying surds. Take a moment to picture the numbers 1, 4, 9, 16, 25 in your head. These are the safe numbers that won't make a surd. Anything else under a root? That's your surd, simplifying surds. Step 1. Once we know what a surd is, the next step is learning how to simplify them. The first step is to find perfect square factors. Let's work through an example. Take the square root of 50. Look at 50 and think, can we break it down into a product that includes a perfect square? Yes. 50 can be written as 25 times 2. Next, we split the root. Square root of 50 becomes square root of 25 times 2, square root of 2. This is just using the rule that square root of a times b equals square root of a times square root of b. Finally, we simplify the perfect square. Square root of 25 equals 5, so the surd becomes 5 square root of 2. A quick tip to remember, always look for the largest perfect square factor first. This ensures your surd is fully simplified and looks neat. Let's do another one together. Another simplifying example. Consider the square root of 72. Step 1. Find a perfect square factor. 72 can be split into 36 times 2. Step 2. Split the root. Square root of 72 equals square root of 36 times 2, square root of 2. Step 3. Simplify the perfect square. Square root of 36 equals 6, so the fully simplified surd is 6 square root of 2. Notice how easy it is once you spot the perfect square. This method works every time and will make surds much less intimidating. Adding and subtracting surds. Now that we can simplify surds, let's talk about adding and subtracting them. There is one key rule. You can only add or subtract like surds. Like surds means the number under the root must be exactly the same. For example, 3 square root of 2 plus 5 square root of 2 equals 8 square root of 2. That works perfectly because both terms are multiples of square root of 2. But 3 square root of 2 plus 4 square root of 3 cannot be simplified. Why? Because the numbers under the roots are different. Square root of 2 is not the same as square root of 3, so you just leave them as they are. Here's a memory trick. Think of surds like algebra letters. Square root of 2 is like x, square root of 3 is like y. You can combine x plus x, but you can't combine x plus y. The same rule applies here with surds. Let's try a few more examples. 2 square root 5 plus 7 square root 5 equals 9 square root 5. And 6 square root 7 minus 3 square root 7 equals 3 square root 7. On the other hand, 4 square root 2 plus 3 square root 3 stays the same. It cannot be simplified. Multiplying surds. Next up is multiplication. The rule here is straightforward. Square root of a times square root of b equals square root of a times b. Let's see some examples. Square root of 2 times square root of 3 equals square root of 6. Simple enough. Another one. Square root of 8 times square root of 2 equals square root of 16, which simplifies to 4. Here's a tip to remember. When multiplying surds, just multiply the numbers under the roots together, then simplify if possible. This rule works every single time and is very reliable. Dividing surds. Dividing surds is just as simple as multiplying them. The rule is square root of a divided by square root of b equals square root of a divided by b. For example, square root of 18 divided by square root of 2 equals square root of 18 divided by 2 equals square root of 9 equals 3. 3. Another example, the square root of 50 divided by the square root of 2 equals the square root of 25 equals 5. A memory tip. Treat division like normal numbers, but always keep it under the root until you can simplify. Check for perfect squares at the end to make sure the surd is fully simplified. Rationalizing the denominator. One more important step in surds is rationalizing the denominator. We don't like having surds at the bottom of fractions. Here's how we fix it. Take 1 divided by the square root of 2. To remove the surd from the bottom, multiply both the top and bottom by the square root of 2. So we get 1 times the square root of 2 divided by square root of 2 times square root of 2 equals square root of 2 divided by 2. Another example, 3 divided by 2 square root of 5. Multiply top and bottom by square root of 5 to get 3 square root of 5 over 5. A memory tip. Think of it as getting rid of the root at the bottom. This is a very common step in Year 9 maths, so it's worth practicing until it feels automatic. Surds are roots that are not whole numbers. Simplify surds by factoring out perfect squares. Add and subtract only like surds. Multiply and divide using the numbers under the roots, then simplify. Rationalize denominators to remove surds from the bottom of fractions. If you remember these steps and practice a few examples, surds will feel a lot easier, and you'll be ready for any Year 9 question. Take your time practicing each step, and soon it will all feel natural. Remember, the more examples you try, the better you'll get at spotting patterns and simplifying quickly.